Today we will start a new chapter, that is atoms and molecules. So in this chapter we will discuss about different rules followed by atoms and molecules while undergoing chemical reaction. Okay, so we know that atoms means these are the basic building block of any element or any matter. Okay, basic building block, that means first two or more atoms they gets combined to form one molecule. All right, and then from molecule we get different substances or different matters. Okay, so first of all let us see or let us discuss two laws. We call both the laws together we call law of chemical combination. Okay, law of chemical combination. Under this topic we will get two law. One is law of conservation of mass, and the other one, that is the law of constant proportion. This one, law of constant proportions. Okay, this one. So here we are going to discuss about two laws. This one, second one. Okay, so first of all, law of conservation of mass. Suppose in this container or conical flask we have taken two things. One is X, the other one is Y. Now X means it can be anything out of these three compounds. One is copper sulfate, barium chloride or lead nitrate. Any one we can take from this. And Y means we can take any one from these three: sodium carbonate, sodium sulfate or sodium chloride. Okay, now when we are pouring X and Y in this conical flask, suppose solution of Y is this part. Okay, this part is Y solution, and solution of X is inside this ignition tube. This small tube is called ignition tube. Inside this ignition tube what we have? We have solution of X. Then the whole thing will be measured. Okay, now we can say or we can see from this figure that solution X and solution Y, they are separated, they are not mixed up, because one is inside this ignition tube and one side is inside the conical flask, so they are not mixed up. So that means since it is not mixed up, we will say that no chemical reaction has taken place. Okay, so once we are measuring this whole measuring the mass of this whole thing, that mass is the mass before reaction, total mass of this thing before reaction. Now what we will do is we will with the help of this thread, you can see one thread is there. If you just pull this thread, what will happen? The solution which is there inside this ignition tube, that solution will get mixed with the solution of Y, and once both the solution gets mixed, now we will get some chemical reaction, and after chemical reaction there will be formation of different new products. Okay, one or more new product. But it is seen that even after this chemical reaction, when the mass is measured, the mass comes as same. Okay, so that means we can infer or we can conclude that mass of X plus Y before reaction and mass of X and Y after reaction remains the same. That's what is mentioned in this conservation of mass in this law. That means in simple what I will write: X plus Y. Okay, X is called reactant, Y is called another reactant. When they mixed up, they form some compound. Just apparently I am writing the name XY. Suppose this compound, we don't know what is the compound, suppose it is XY. So the mass of X, suppose just an example, okay, suppose it is 1 gram. Mass of Y is suppose 2 gram. So what is the total mass? 3 gram. So in product side, this is called reactant side, this is called product side. In product side also, XY, after forming the product, the total mass of it will be obviously 3 gram. So mass is conserved. Conserved means it is not going to change. So the total mass of reactant will be equal to the total mass of the product. That is said in law of conservation of mass. Okay, I hope it is clear. Then another law, both the laws are under this one only. Okay, law of chemical combination. So another law is here, law of constant proportion. So law of constant proportion means whenever a compound is formed out of two or more element, they always get combined in some constant proportion. Say for example, I am giving an example of water, H2O. Okay, so H2O, it is seen that when it forms water, in water hydrogen and oxygen, they remain in which ratio? 1:8. This ratio is always constant. That water, whether you take this water from pond, whether you take this water from any other source, the composition, that means hydrogen and oxygen, that will remain always in this ratio, which is 1:8. Okay, that means, suppose for an example, if we take 9 gram of water, 9 gram of water, in this 9 gram of water, 1 gram will be, what is that? 1 gram will be hydrogen and 8 gram will be oxygen. So if you take the ratio, certainly it comes as 1:8. Okay, right? Now suppose if you take this water, you are taking, this time it is not 9 gram, suppose it is 18 gram, 18 gram of water, double of 9. Okay, so if this is 18 gram of water, how much hydrogen or how much oxygen will be present? Hydrogen will be 2 gram, oxygen will be 16 gram. 16 plus 2 is 18. And why 2 and 16? Because if you divide 2 and 16 with 2, what we are getting? We are getting 1:8. And as just now I told that their ratio will always be 1:8. So this is called law of constant proportion. Similarly, another example is given, ammonia. Ammonia is a compound of nitrogen and hydrogen. And in ammonia, nitrogen and hydrogen, in which proportion they are present? 14:3. That means out of 17 gram of ammonia, 14 gram will be nitrogen and 3 gram will be hydrogen. Okay, so that is called law of constant proportion. So for today, this much only. Thank you.